All right, welcome back. So, in the last few videos, we were looking at the overall process of doing a hypothesis test for proportions. This so-called z-test. Okay, it's called a z-test because we use the z distribution in figuring out if our data that we collected was due to random chance, or if it's actually possibly suggests that there's a different status quo, right? Okay, so in this example, it's actually slightly different than the last slide on the last video. The content is the same. I have just added more information that is necessary to do the question, specifically the sample size, totally spaced on that when I was writing the question. And then I reworded the research question to be a bit more consistent with what we've been saying in the past. So otherwise, the process will still be the same. I just needed to add more information so you can actually do it. Okay, so let's get into it, and we'll see what we get. So a Wyoming arborist states that 80% of the trees in Medbo National Forest are lodgepole pines. Okay, so 80%. The claim is, or the status quo is, 80% of the trees are lodgepole pines. Okay. However, a Colorado arborist believes that the actual proportion is not 80%. They just disagree with you. Okay, so there's no directionality to their question. They just think that it is not 80%. So they both go out and get a proper sample of 100 acres, and they find that, on average, 73% of the trees were lodgepole pines. Okay, so now this is our new sort of proposed new proportion. Okay, now they just don't know what to do, so they contact you, the resident statistician, and they ask, do we have enough evidence to suggest that the actual proportion is not 80%? Okay, and you say, for sure, I can conduct a hypothesis test, and that'll be that. But first, you gotta get paid. And you're getting paid a lot for this one thing. So, and then use an alpha of 0.05, right? So this alpha is just saying that we're cool with there being a 5% chance that our data is due to randomness, right? And the smaller our p-value is compared to this, the better, right? I'll get into that interpretation here in just a little bit. So let's just get into it. I've got a new blank page here, and we'll do it step by step, very similar to what I was showing y'all in the last vids. Okay, so the first step is to write down your research question, which in this case is there enough evidence to suggest that the actual proportion is not 80%? Or, are lodgepole pines really not 80% of the trees in Medbo? Okay, that's our research question. I'm not going to write it down because it's already there, but we will write down step 2, and let me zoom in here. Okay, so step 2. Step 2 is sort of translating our research question into a null and alternative hypothesis. Okay, so we got to find H naught, and we got to find HA, right? Or at least write it down, right? So we got to do a little bit of interpretation. It should be fairly clear, hopefully. If it's not, that's okay. But our H naught, our null hypothesis, is just the status quo, right? Which in this case is this, okay? And typically you can kind of see the order too. Usually the status quo is the thing that's suggested first, and then somebody comes up to you and opposes that, right? Opposes that. Okay, so the status quo. What is the status quo? Well, the status quo is that the proportion of trees, we can just write it as this. P equals 80%, right? Or 0.8, 0.8, okay? And then the alternative hypothesis is the thing that is going against the grain, right? It's the opposite, essentially, of the status quo, right? Where in this case, the Colorado arborist believes that the actual proportion is not 80%, right? How do we write that? Great question. That's just going to be P does not equal. We put the cross through the equal sign. And then we write down the proportion, right? That we don't think actually is the proportion, right? So the null hypothesis, proportion equals, proportion of trees in this case, equals 0.8. And then the alternative hypothesis, this is the one that we want to support, right? That alternative hypothesis is P does not, the proportion of trees is not 80%. Okay, so that's fine. What about step 3? Well, that's when we find our test statistic, which is so hard to say. Oh my gosh. Statistic. So hard to spell too. Gosh. Statistic. Dummy. Okay. My bad. So, how do we do that? Well, we're working with proportions, right? And we're also working in sort of the Z world, right? So, either go back to the slides to go find that formula, or I can just give it to you now. Our formula for finding this test statistic, the sort of summary statistic in the frame of the null hypothesis, is our sample that we got, right, that we went out to go collect, minus the null proportion, right, or whatever stated here, right, that's easy enough. Okay, and this is all divided by, here we go, okay. So we have, this is not, I'm going to write it a little out of order as far as operations go, but we have our P naught, right, our null proportion, and then times 1 minus that, right? And all this is, right, all this is saying is that we've got the proportion of trees, right, the null proportion of trees is 0.8, and then the proportion of everything else, right? So this is the sort of thing of interest. This is everything else, right? The proportion that are not the lodgepole pines. And this is all divided by n. And that's all, this denominator is all underneath the square root sign, right? Cool. Okay. So this is another word for the standard error. Very similar to standard deviation. And we can kind of see the similarities between calculating a z-score and calculating this test statistic, right? So easy enough. We just need to plug and chug, right? So let's write out what we have. So P, let me use like this hunter green. So P hat, let's go back to the question. P hat is what we got, right? Which in this case, it's not 80%, but it's what we went out to go against the null hypothesis, right? So that's 0.73. 0.73, very cool. P naught is our null proportion, so that's 0.8. We could do 1 minus P naught 2 if we wanted to be very, very detail oriented. And all that is 1 minus 0.8, which is 0.2. So that's cool. I got a text. I'm so popular. Okay, and then n, let me actually double check that. N is 100. Great. Okay? So we got everything, right? We got everything. So all we're going to do is plug and chug. So I'll put everything in its respective spot. And then, let's see, so that's 0.8. We can write it either way, but I'll leave it like this. Divided by 100. This is all underneath the square root. Okay? Very cool, very cool. And it turns out that this equals, you can plug it in your calculator. Actually, just a quick note. This, be very careful with your parentheses and order of operations and everything. This sometimes can be a little hard to make sure you've got everything in the correct order, and as far as like order of operations go and everything. So calculator is the best thing to use here. If you're good with the phone calculator, that's fine. But maybe like a TI-84 or whatever, you can kind of see things just a bit easier. But regardless, this turns out to be negative, whoa, and I'll write it in this color, negative 1.75. That's our test statistic. Okay. So what do we do with that? Well, I can tell you sort of the the mathematical explanation of this thing, right? Or we don't have to worry about that, and we can just go ahead and throw this value. Let me get rid of it here. No spoilers, right? We can just throw that value in here, right? Because essentially all we're doing is throwing in a z-score, right? And we just want to figure out essentially what the probability of seeing our data was given that the null is true, assuming that the null is true, right? Sort of doing this, how much these curves are overlapping, right? Again, details that are not totally necessary to get hung up on. So we'll just go ahead and throw it in here. Negative 1.75. And just remember that since this question was a two-tailed question, there's no directionality to it. This is how you want the plot to look. You can kind of, the sort of trick here is that the two tails, right, has got a 2 in front of it in this little drop-down menu, right? So that's fine. This is all good. So essentially what we're doing is we're just trying to figure out, given that our data, is our data, and assuming that the null is true, we're figuring out the probability of seeing our data, right? Given that the status quo is the status quo, okay? And so the two-tailed test just looks on both ends, right? It looks on both ends of this. Okay, it's essentially looking at the absolute value of this test statistic. Again, no worry about getting hung up with that. And it turns out that our p-value now, step 4, let me switch back here. Yes. Step 4 is finding the p-value, and which we just did, right? So that's right here. So we plugged in our test statistic, our test stastic, and we get out the area underneath the curve, right? Which in this case is 0.08. 0.08. We'll write it as p-val. Only because we have a bunch of different types of p over here, right? P hat, p naught. So we'll just say p-val so we don't get confused. And that equals 0.08. Okay, so now what do we have to do? Well, we have to make a step 5 decision, right? No, why am I writing it over here? Let me get a whole new page. Whoop, sweet. Okay. Step 5, decision. And let's sort of write out the general idea here, right? So if p-val, the p-value is less than alpha, and let's write our alpha, it's 0.05, right? Then if it's less, so we reject, let me write it, we reject H naught, our null hypothesis. Okay? If, give more space, if the p-val is greater than alpha, we fail to reject H naught, our null hypothesis. Okay, very cool, very cool. So let's bring this all back together. What's our p-value? Our p-value was, let's see, 0.08. Our alpha is 0.05. What do we do? What do we do? Well, 0.8 is greater than 0.05, right? So that means that p is greater than alpha. What do we do? Based on this test, we fail to reject H naught. Okay, you can underline it like so. When you're doing it for homeworks or tests or for whatever, this sort of structure is fine. You can also just say, since, actually I'll write it out. I'll replace this. Just so long I can see your process. Really is all I care about. But we'll say, since p-val is greater than alpha, by just a little bit, but even if it is just a little bit, it's still more than 0.05. Since p-val is greater than alpha, we, or you, or I, or whoever, we fail to reject the null hypothesis. Okay, easy enough, right? So the interpretation here, the interpretation with this p-value is that given that the null hypothesis is true, there's an 8% chance. There's an 8% chance that our data that we saw, this proportion of 0.73, 73%, the probability of seeing our data, or the probability that our data is just up to randomness, up to chance, is 8%. This 8%, right? Which is too high for us, based on this criteria, right? We're cool. We're fine with a 5% chance and lower, but since 8 is higher than 5, right? We don't have enough evidence. We don't have enough evidence against the null hypothesis. Okay, so then the last step, step 6, we got to write out. We got to write this thing out. So you can go to the template, and that's fine, copy and paste, whatever. I'm going to write out the last optional bit where it's the sort of English translation of it all. So we'll say that since the p-value was greater than 0.05, we do not have significant evidence that, okay, let's see, lodge, whoa. Okay, let's see, since p-value was greater than 0.05, we do not have significant evidence that lodgepole pines in Medbo do not make up 80% of the trees, right? Dang, I keep getting text. Okay, so since the p-value is greater than 0.05, we do not have significant evidence that lodgepole pines in Medbo National Forest do not make up 80%. Now, this is a kind of a convoluted way of saying that most likely, based on this data, based on the test that we did, most likely, lodgepole pines in Medbo are 80%, right? This is unchanged, right? This is unchanged. Okay, so, so this is the general idea here, where, you just want to make sure that in part this is correct, because then everything after this is, totally dependent on this answer right here, whatever this value is. And then also just make sure that you read the question too, because this would be slightly different. This would be a slightly different process if they said is less than 80% or is more than 80%, right? The process itself is the same. It's just at this last step would be slightly different, right? If there was direction to it, if they said, I actually think that there's less than 80%, then what we would do is we would just chop this value, this p-value, in half. We would chop that in half. We're not doing it in this example. We'll do this in the next example. But this is the only place where it would change, right? The process itself is fairly similar. Okay, so with that, try it out yourself if you haven't already, and then I will see you in the next example.